This is a demonstration of how malware writers and hackers make use of alternate data stream, ADS, to hide their malicious code. Malware writers and hackers have been using various methods to evade or hide from antivirus detection ever since antivirus software existed. One method favoured by malware writers and hackers on Microsoft Windows platforms is alternate data stream, ADS. With ADS, one file can be inserted into another container or host file. Adding the extra file data to the host will not change the file size of the container file, and its file hash value does not change either. In effect, the extra data is hidden from most tools, such as File Explorer and many security tools. What attracts malware writers and hackers to use ADS is that the malware file can be hidden and made invisible. The hidden file data can still be accessed and executed. For example, if the inserted data is an executable file, the hidden file can be executed. If the inserted data is a PowerPoint file, then it can be accessed as a PowerPoint file. Special tools are needed to reveal the presence of ADS embedded files. In this demonstration, we will use Notepad.exe as the container or host file. The Windows calculator, calc.exe, is used as the executable to be inserted into the container file using ADS. The file can be inserted into Notepad by simple commands on the command line or by using standard programming calls, so malware can automate the process without any help from other specialist software or libraries. The two files that we will be using are calc.exe and Notepad.exe. We will insert calc.exe into Notepad.exe, but firstly we will take the MD5 hash value of Notepad.exe before we do anything to it. Secondly, we will check the file size on the command line. And as we can see, it is 68 kilobytes or 69,120 bytes. We can also see that calc.exe is 112 kilobytes or 122,880 bytes. Now, we insert calc.exe inside Notepad.exe. We do this from the command line, and it is remarkably simple to do. The command used is type, followed by the file name of the file for insertion, a greater than bracket, the name of the host file, a colon with no spaces either side, and the name of the file to be inserted again. In our case, this reads as type, calc.exe, a greater than bracket, Notepad.exe, a colon with no spaces either side, and calc.exe. HDF will block this operation, so for the purposes of this demo, we will turn it off. And now we will run the command, and already calc.exe has been inserted into Notepad.exe. To show that the insertion has been successful, we will run calc.exe from within Notepad.exe using the start command, and, as can be seen, calculator executes. In Windows Explorer, Notepad.exe's size is still reported as 68 kilobytes. Using Task Manager, we can see that the calculator process is not running here under the name calc.exe. Instead, it is running under Notepad.exe, and this is a Trojan scenario. We will now check the file size of the Trojan Notepad.exe again on the command line. We'd perhaps expect that the file size would be larger than 68 kilobytes after calc.exe had been inserted, but the size remains at 68 kilobytes as before. Then, if we check the MD5 value of the Trojan Notepad.exe file and compare it to the original, we can see that, just like the file size, it hasn't changed. And because most antivirus software relies on hash value, for example MD5, to identify malware, such an attack would not be detected. Checking the HDF log files reveals that the creation of the Notepad.exe with the calculator embedded inside was allowed, as signified by code 0 in this column. This is because HDF was turned off. The injected file can be called anything that we like. For example, here we will insert calc.exe again, but this time we'll name it as a string of full stops. Again, we use the start command to run this strangely named embedded file, closing the last instance before running this one. It runs without any problems. We have successfully inserted another calc.exe inside Notepad.exe. Now we have two versions of calc.exe inside Notepad, one named calc.exe and the other named as a string of full stops, and yet we can see that the file size of Notepad.exe has still not changed, remaining at 68 bytes. If we check the MD5 value of the new Notepad.exe, we can see that it hasn't changed either. It is still the same as the second version of Notepad.exe which we created, which in turn was the same as the original Notepad.exe file. The MD5 value and file size is the same, even though we have two versions of calc.exe inserted and named differently. Let's have a look at the HDF log file. It shows what has happened. Our first modification is still there, where we took Notepad.exe and embedded calc.exe named as itself, and also our second modification is there, where we took the already modified Notepad.exe and added another version of calc.exe named as a string of full stops. So the HDF logs reveal everything we have done, and of course the calculator process does not appear in Task Manager. The next part of this demonstration shows what happens when HDF protection is turned on when trying to carry out this operation. We will try to do the same thing again, and this time we will take Notepad.exe and embed calc.exe named as test.exe. As soon as the command is run, we see the message "Access is denied" as expected. So our last attempt at insertion via ADS has failed. If we take a look at the HDF log file, we can see the code 1 in the column next to our attempted modification, meaning that HDF blocked the Notepad.exe with test.exe inserted inside it from being written to the disk. For more information on Abatis HDF, please visit www.abatis-hdf.com.